The flow of traffic is a constant 60 miles per hour. 20 feet in front of you, your front bumper to their rear, there is a car 18 feet long. You only have a half mile before your right-hand one-lane exit comes up. You are driving one lane to the left of the far right lane. Do not try this. If you floor it and speed up to 74 miles per hour, instantly will you pass them in time to get off on your exit. Your car is 16 feet long. Mathematically prove whether this is safe or not, and would you make the exit? Answer using time and distance as evidence. First, you must realize that there are two separate things that are occurring in this problem. One is a faster car traveling, and the other is a slower car traveling. Therefore, you have to create two equations, one for each. Based on this, you know the distance that they have to drive, but you need to find their time, because if they are at the same place at the same time, then you have an accident. So, you need to adjust the distance driven according to their car lengths. Remember, if your front bumper is only just past their rear bumper and you get over, then you've crashed. If your front bumper is only just past their front bumper, then again, you crash. You have to make sure that your rear bumper has cleared their front bumper before you change lanes. So instead of calculating the half-mile distance only, you have to either add or subtract to that distance. With the faster car being behind the half-mile mark, you have to add the length of that car to the half-mile, because again, the rear bumper has to clear the exit. In short, the faster car, which is behind the line, has farther or more to drive. This is why you add. Use that distance with the faster speed and you are good to go. You now know how long it took for that faster car to clear the exit. Next, with the slower car, you have to realize that it is ahead of the half-mile mark and has less to drive. The less indicates subtraction. Take the half mile and subtract the slower car's length and gap from the half-mile mark, and you have the distance the slower car has to drive to clear the exit. As with the other car, use this modified distance to calculate the time to clear the exit for the slower car. Now, how do you figure out how far apart the cars are distance-wise? Use the difference in speed to determine the difference in the distance. Realize that one car going faster than another covers more distance because it is driving with more speed. So if you enter that difference in speed or extra speed into the distance, speed, and time formula, then you find out how far the cars were apart after the half mile. At this point, you must compensate for the gap and the car lengths by subtracting. You finally have both the time and distance they are apart. At this point, you can mathematically determine if there is enough distance and time to safely pass.